had instances where there was so much iron in the water that you would get cooling towers that look like chocolate milk.
Really?
Yeah.
Wow.
So circumstance, the recommendation is turn the system over, flush it out, hit it with large doses of corrosion inhibitor, and try to get it back steady. But it can be a tenuous process.
Welcome to the Facility Focus podcast presented by New Standard Cleaning. This is the show where we talk to facilities professionals and building service contractors about the work that goes into keeping and maintaining buildings. Today, I'm joined by a special guest, Steve Maring. He is a water treatment consultant with Kroff Chemical. He's based in Michigan. We're going to be talking about water treatment, water systems, and how they work in different types of facilities. If you enjoy the show, please like and subscribe, share it with a friend. Let's get into it. Hey, Steve, welcome to the podcast.
Hey, Matt, thanks for having me.
Well, thank you for coming. You're a longtime friend, and I appreciate you coming on here to do this, and I look forward to learning even more about what you do. I know some from being a friend of yours, obviously, but I'm hoping to come away with some more. So why don't you start off by telling us what a water treatment consultant does?
Sure. Yeah, well, I've been a water treatment expert, consultant, engineer, whatever you want to call it. My title is water treatment consultant. I work for a company based in Pittsburgh, but have a division here in West Michigan. Essentially what we do is we come alongside businesses anywhere from commercial, industrial, heavy industrial, and we help them with their water problems. And I keep that extremely broad because businesses use water in a myriad of different ways all across different industries. So in commercial office space, typically we're dealing with HVAC. That could be cooling towers, that could be closed hydronic loops, could be boilers for heating, and sometimes it's even domestic potable water. In an industrial sense, we still deal with those boilers and cooling water, but in that respect, they're often used for processes or even solvents. So really, our job is to field questions that deal with water and try to provide the best solution to their issue. Me personally, we're going to attempt to either fix an issue with equipment that conditions water, something like a softener or reverse osmosis, or we're going to apply chemicals that solve an issue that can be created when using water for these applications. But sometimes those aren't the best fit. And I like to think of consulting as not just selling someone a final product, but also using a network of experts to try to find the best solution. Because, as much as you want to sell your product, sometimes it just doesn't fit, and that would be the wrong thing to do for the customer.
Sure. So, yeah, each facility is different on how they use water and how water impacts what they do there on a day-to-day basis.
Sure.
So how did you get into water treatment?
Surreptitious route. I went to school for biology, realized, 3/4 of the way through my degree that I didn't want to go into medicine. I didn't want to go into research, and didn't really know what I wanted to do. So I took a job in operations for a water treatment company called HOH in Illinois, in Palatine, Illinois. And they provided me the opportunity to learn and grow the industry. And that was that was a really great way to get into it because I kind of got to see the business from the inside out. I got to see operationally what was going on first, and then head out into the field where, quite frankly, I didn't know up from down. Most of the people that are in this career are, in the engineering field where they study, so they have a good baseline knowledge. So I was able to take some of the biology and chemistry into it, but there was a steep learning curve that, I still experience. I mean, quite frankly, there is just mountains of information and always new problems that it keeps it fun. There's never really a dull moment.
Yeah, and no two buildings are the same. It seems very technical. From when I was doing a little bit of research for this conversation, they started talking chemical, and I was immediately out.
Well, and luckily, Kroff, my current company, and HOH was the same. They employ people much smarter than me. That allows me a good knowledge base to draw upon, so that when we have challenges, there's some really smart people behind the chemistry that help. I guess I would call myself an applied chemist, right? I would never call myself a chemist necessarily, but you get good at applying it in the right situations.
You're taking sort of the science out to the field.
A little bit,
yeah.
So a little less technical, a little more solutions oriented.
Right.
Yeah.
So let's just quickly go over some of the basic components of water systems in different types of facilities.
Sure.
We have cooling towers, boilers. We have closed loop systems, open loop systems. Can you just quickly touch on each one of those just for a basic foundation of the systems?
Yeah. So, we're going to start with a commercial office building and then maybe transition to like an industrial application. So, when I was in Chicagoland, I would deal with a lot of Class A commercial office buildings. So big downtown high-rises office space. Those buildings tended to have 2 or 3 water systems. That would be a cooling tower, sometimes known as evaporative cooling. And what that does is it's essentially using evaporation to cool down water, which then exchanges heat with an internal hydronic loop inside of a chiller or an industrial air conditioner. It would remove heat from that. The cool water would be circulated throughout the building through heat exchangers, air handlers, and that provides the comfort cooling within the building. And then for heating, those systems would either have a closed heating loop, which would be heated with boilers, or for older buildings, they would tend to have steam systems. So you could either have hot water or steam for heating, and then you would have cooling for the air conditioners. So, go on.
I was going to ask if the boiler is that also connected to the cooling side of things, or two totally separate systems?
They can theoretically be connected. You can use the same water for heating and cooling depending on the season. That would be referred to as a 4-pipe or a 2-pipe system. So a 2-pipe system refers to the same loop being used for heating and cooling, and a 4-pipe system would mean the systems are completely separate.
Okay.
2-pipe, obviously, infrastructure-wise, is less expensive to build, but it doesn't give you the ability to run both at the same time or to switch over from one to the other quickly.
Okay.
So there were certainly benefits and drawbacks to both.
Right. Do these systems have a control box or some sort of monitoring system there at the facility?
Oh, certainly. I mean, they're very complex systems. So for the cooling tower, we'll kind of go top down is how I see like a commercial office building. If you're driving around, you might see these big steel boxes, galvanized steel or stainless steel, and they're sitting on the roof, and you kind of go, well, what is that thing? Mm-hmm. Well, really all it is it's a big fan and spray pumps. So water is then taken from the air conditioner, the chiller, whatever you want to call it, heat exchanger, and it's pumped up through the top of the cooling tower where it's dispersed into droplets. As it's dispersed into droplets, air typically is coming up through the droplets and removing heat through evaporation. The best way to describe it is if you ever go to the beach and you get water on your skin, and as it dries, it feels like it's cooling. It's the same principle.
Interesting.
So
That's
in
a
that
great.
case, it's removing heat from your skin, and in an industrial or commercial application, it's removing heat from the water, which is taking heat away from the building.
Okay, and that's an open loop system.
That would be considered an open loop. In that situation, water is constantly being added to the system, and water is always being evaporated from the system.
And it's open to the atmosphere,
Correct.
the air around it,
Right.
which
So,
presents other potential problems.
oh, certainly. Yeah. The other type of cooling that you'll often see would be called dry coolers. And in that situation, the closed loop is actually running through heat exchangers that are exposed to the atmosphere, but they're not evaporating. They're just using fan cooling, similar to how your home air conditioning would work.
Okay.
Yeah.
Okay.
Typically, and again, this is a little outside my wheelhouse, but my understanding is it depends on the amount of tonnage, which is how an engineer might decide on if you want an open cooling tower or a closed.
Okay.
Yeah.
So then, what are the problems we're trying to solve for here by applying water treatment?
Well, for cooling towers, it's generally it's generally four things. One is scale. As you evaporate pure water, the minerality that's naturally occurring in the water that you're bringing into the cooling tower will condense, or sometimes it's referred to cycling up. So let's say you come in with 100 ppm of calcium magnesium. As you're removing pure water, the concentration of calcium magnesium increases. As that increases, the propensity to create scale, or you'd know it as lime scale, becomes greater and greater. So what we try to do when it comes to scaling is we apply scale and corrosion inhibitors that keep the scale from forming while also maintaining efficiency. There's no reason why a building couldn't just run water in and run water out. What starts to happen is it becomes cost prohibitive, especially in areas of high water stress or just the cost of water in general. So we're always trying to ride the line between keeping systems clean of scale while also maintaining efficiency from an energy and water standpoint. As we do that, you also need to be cognizant of two other things, which is corrosion, right? Some waters are corrosive. Soft water is corrosive to mild steel and copper. So we're applying both scale inhibitors and corrosion inhibitors to maintain the asset life of your HVAC system. So we don't want it to scale, but we also don't want it to corrode. So we're trying to maintain a certain balance of minerality in the water as well as chemistry in the water to keep systems scale free, corrosion free, and to get the max asset life to protect that capital expense. Because chillers and cooling towers and plumbing, if you've ever gotten a plumbing bill, plumbers are expensive, and for good reason. I mean, what they do is very difficult. But it's not something you want to be doing more than you have to.
Right.
And then the last thing when it comes to cooling towers, which is always very important, but it's become significantly more important, especially in the commercial office space, is water safety. And what that means is there is always going to be a level of biological activity in an open system. Our job is to keep that in control. Something that you probably have heard of is Legionnaire's disease. Legionella is a common ubiquitous bacteria that likely at any one time is in your cooling tower. But if it is able to take root and create large populations of Legionella bacteria in your cooling tower, if someone were to inhale those droplets, and oftentimes someone who's immunocompromised, that's what causes Legionnaire's disease and can be fatal.
Wow.
So a lot of office buildings have taken that very, very seriously. And so we need to apply biocides similar to a swimming pool, just, not ones that you want to go swimming in.
Right. In concept. Yeah.
Yeah, to keep those bugs at bay.
Right.
The goal is not to keep things sterile. It's to keep the bacteria at a safe level.
So what are,
Yeah, sorry, go on.
yeah, I was just going to ask, what are sort of the first signs or, some of the signs? I know that you guys do testing. Are there also visual assessments that are made? How do you guys go about identifying?
One tool we use they're called dip slides. They're little portable auger plates. And you basically can take a water sample, dip the auger plate in, and incubate it for 48 to 72 hours. And that'll give you an idea of how many aerobic cultures you have, or mold or slime formers. There's also other ways to do it. ATP is one of them. But visually, it can be quite simple. Is there slime forming in your cooling tower, specifically in the areas of constant water contact? Is there significant algae? Systems that aren't treated really well will get algae blooms, and it'll look like a green swimming pool. Those are all pretty good indicators that you're not controlling biology and mold and slime formers very well. One thing that does trip people up often is areas of wet dry. So what that refers to is if you have a cooling tower in direct sunlight in the summer and you have water splashing in an area but not of constant contact, and then sunlight gets on that, sometimes you can have little bits of algae on the side of your cooling tower. That doesn't mean that you're not doing everything completely perfectly. It's just you're kind of creating a perfect environment to grow. So that's a call I would get a lot is, well, hey, Steve, why is there, a little bit of green on the side of my cooling tower? Well, if the biocide I'm applying isn't always getting there, well, it's not going to be reasonable to expect it to work.
It makes me wonder those, there's buildings that are not occupied, non-operating buildings, whether they're old or switching hands, makes me wonder if they turn the water off. What are these systems like to reopen once a building has been offline for a long time?
It's a great question, and it's something I've dealt with quite a few times. In my experience, many of them would continue running, because temperature control, even in an unoccupied building, is important to just maintain the health of the building. But there were instances where, yeah, sure, management companies are changing hands, facility people are changing jobs. We want to save money, stuff gets shut off. And when things are shut off or laid up, as we might refer to it, you can get a lot of problems. Specifically, say like you have cooling tower piping that's carbon steel, you have no corrosion inhibitors in it, and you lay it up with water. Well, think of a piece of steel sitting in the rain. And then when you start it back up, all that dirt, debris, mill scale, corrosion, it's got to go somewhere. And I had instances where there was so much iron in the water that you would get cooling towers that look like chocolate milk.
Really?
Yeah.
Wow.
So in that circumstance, the recommendation is turn the system over, flush it out, hit it with large doses of corrosion inhibitor, and try to get it back steady. But it can be a tenuous process, and just to jump to closed systems, the same thing would happen. Right? If you had a closed system that was severely neglected, oftentimes, you'd have to filter it excessively and purge it to try to get it back to baseline.
Okay.
Yeah.
Yeah, that's a handful, for sure.
Yeah. Yeah, those aren't terribly fun
Yeah.
because they never go as quickly as you want.
If there's how sensitive are these cooling towers to like construction nearby or Canadian wildfires? Like, are they that, like, can things like that move the needle on what's going on inside the system?
Most certainly.
Yeah.
Cooling towers effectively are large air scrubbers. They're pulling in enormous amounts of air and everything that's in that air. So if you have lots of construction, wildfires, it'll pull all that debris into your cooling tower, and it's now your job to make sure it doesn't settle in places it shouldn't. So part of our programs are adding dispersants along with our corrosion inhibitors to make sure that dirt and debris don't cause issues. But dirt and debris is always going to be part of operating a cooling tower, and the location of that cooling tower does certainly impact that. And things like dirt and debris can harbor bacteria. I've seen instances where people aren't properly doing shutdowns and cooling out or cleaning out the cooling tower that has an inch or two of dirt and debris at the bottom of it. Well, if you create an area for bacteria to thrive underneath all that dirt and debris, you can have some big issues.
Yeah. So you've probably been on many rooftops.
I have.
What are some of the best views that you've seen?
Ooh. One of my favorites, there's a apartment building in downtown Chicago called Wolf Point West. And they had a mechanical room that looked straight down the north branch of the Chicago River, which was always fun to go there. On top of Chase Tower was another one. That was a really fun one. On top of the Hancock building was a really fun one. Fun fact about the Hancock building, they have a exact half-court replica of the 1990s Chicago Bulls court.
Really?
Yeah. So in the mechanical room amongst the chillers and the boilers and all their mechanical stuff is a half a Chicago Bulls court that Michael Jordan and his teammates would get shots up. And I was told it was because two reasons. One, I think the Ritz-Carlton is there, so the Bulls would often stay in that hotel, even though like it was home games. I think they would stay there, maybe for the playoffs. And I guess the owner at the time was an enormous Chicago Bulls fan.
Mm-hmm.
So that was
That's
cool
cool.
to see.
That's
Yeah.
cool.
Got pictures somewhere.
Nice.
Yeah.
Just standing on the edge of the building like Spider-Man with your company's logo on the back.
Yeah, it was. It would get. You never get too close to the edge of the building.
Obviously.
At least I didn't. But climbing a ladder up a cooling tower in the foggy rain on top of a skyscraper can be a nervy moment.
Right.
Yeah.
Cool. So let's shift to boilers a little bit.
Sure.
And can you tell us a little bit about the biggest issues that come with water quality in boiler systems?
And boilers are some of my favorite. Like I mentioned a little bit earlier, boilers have been for the most part phased out in terms of new construction when it comes to heating buildings, which is why like if you see radiant heat at all, it's going to be hot water. But there's still a lot of facilities operating with steam heating. But for the most part, you see most of the boilers now in process applications where the steam is being used to heat process components or being directly injected into some sort of process. Mm-hmm. So the general idea of a boiler is not complicated. I mean, you're adding water to a pressure vessel. That pressure vessel is heated. You're creating X amount of pounds of steam, and then that steam is distributed where you need it. The main problems are not dissimilar to cooling towers. It's just different how you go about treating it. I would say predominantly the main issue that I run into with steam boilers is going to be scaling again. And the propensity to scale in a cooling tower, I'm sorry, in a boiler is even higher than a cooling tower, because what makes calcium and magnesium scaled kind of unique in nature is that when you apply heat to it, it has a propensity to drop out of solution. So if you're not controlling or treating a boiler well, you can get scaling on the heat exchange surfaces or the tubes inside of a boiler. And that causes a myriad of problems. One is scale is an excellent insulator. So the more scale that you form on your heat exchange surfaces, the more a facility is going to have to pay to create the same amount of steam. So one, it's a big cost. Second, it's a safety hazard. The more heat you apply, the hotter the system gets. If you create hot spots, you can create failure points. And unfortunately, it seems like a few times every year you hear about, a factory explosion. And oftentimes that occurs around a steam boiler that has been used and abused for many, many years. And these boilers can explode.
Wow,
So
I didn't know that. Important to stay on top of.
yes, it is.
Or, I mean, that's
And,
probably an example of major neglect.
it's major neglect.
Yeah.
But it's rarely a surprise, quite frankly. So the most critical aspect of any boiler treatment is pre-treatment, meaning for the most part, if you want to keep scale from forming in your boiler, you want to remove that scale before it's ever in the boiler, which means softeners, it means reverse osmosis units, but sometimes it's just a matter of applying the correct chemistry to maintain that scale and keep it in solution.
So
Yeah.
that makes me, this water's coming from city water, is the origin of it. Do water treatment programs greatly vary across the state or the region or even the country, just depending on the water that they have there?
They absolutely do. So if you're on Great Lakes water, which is what I'm most familiar with, the water stays very consistent. But as soon as I get into inland Michigan or upper Michigan, I have a lot of facilities that are on wells. And that's when things get complicated. Again, the principles remain the same, but how you operate can change. So, for example, if I have a boiler that's on Great Lakes water at 100 ppm hardness, and it's a relatively low pressure system, sometimes you can get away with running hard water and maintaining certain chemical levels to keep that hardness in solution, as long as you don't overcycle the boiler. Most of the time you're going to want a softener just as a belt to your suspenders. But in, let's say, a well water application where my hardness goes from 100 to 800, or the well varies in hardness from 500 to 1,000 ppm of hardness, in those situations, you definitely need some sort of pre-treatment application. And then it comes down to, the return on investment for those pre-treatment applications. So some people opt for reverse osmosis, which essentially provides you with extremely pure water that has been stripped of the majority of its minerality, and that allows your boiler to run higher and higher cycles, which gains you a tremendous amount of efficiency from an energy and water usage standpoint, but it comes with a higher capital cost. So those are analyses we do for people all the time, and it really depends on a myriad of factors on what the water is being used for, how much water they're using, the quality of the water coming in, things like that.
all those things are
Yeah.
taken into consideration,
Yep.
which is what you guys do on the consulting side as well.
Yeah. Yeah. I mean, the goal really is to, you know, try not to have a one size fits all. It's a phrase definitely overused in water treatment, but it's like custom solutions for custom problems.
Mm.
But it's true. I mean, what works in Chicagoland for a steam boiler does not work for, a steam boiler in Odessa, Texas.
Hmm. Hmm. Makes sense. Um, you mentioned before we started recording that that wastewater is a big part of the work that you do.
Hmm.
So, if you'd like to, tell us more about that.
Yeah, yeah. Wastewater is definitely where I find the most challenge, but the most fun. And it tends to have the most immediate impact. So I'll just an overview would be facilities are constantly using water for one process or another, and that water, as it's being used as a solvent, as a process fluid, what have you, it generally picks up contaminants that cannot be directly discharged either back to a city POTW, which is a publicly owned treatment works, or even more critical would be someone discharging directly to the watershed. So those facilities are permitted, and those permits have specific regulations on what the water needs to be treated to before it can be discharged without the risk of fines, surcharges, or in worst case scenario, having your facility shut down.
Hmm. Yeah.
So, for example, I work with a poultry facility that discharges over 1 million gallons a day, and they are under strict limitations on how well that water has to be treated for them to stay in compliance.
Hmm.
And this is where wastewater differs a lot from boilers and cooling. Is it can be very much an art form. What seems to work here doesn't want to work over here, or what seems to work in the summer doesn't want to work in the winter. This piece of equipment works better for this type of waste. This piece of equipment works better for this type of waste. And so in those situations, what we're doing is we're taking a look at the water, figuring out if chemical treatment, biological treatment, mechanical treatment, you never really know until you dig into exactly what contaminants you need to remove to keep your customers in compliance. And it's when you deal with industrial, that's significantly different than if you're dealing with municipal. Now, there's some congruence, there's overlap, but typically, if you're on the municipal side, you're bringing it into large lagoons, large clarifiers, you're letting biology chew up most of those nutrients, and you have really large residency time. In a facility, you might only have a small corner of a giant facility that takes in all the water, and you're responsible for getting it out. And in that situation, we're generally applying a combination of pH adjustments, coagulants, flocculants, metals precipitants, and a variety of other things to get the water to a point where that facility says, okay, I can discharge this without getting fined. And easier said than done.
Yeah. It sounds like a lot of testing and
A lot of
fixing
testing.
and adjusting and going back and constantly monitoring the situation because the impacts could be huge.
It's very expensive too.
Yeah. Yeah.
I'll give you an example of just how variable things can become. I have a battery manufacturer. They make lead acid batteries for fork trucks and things like that. And for years, we had a program. They apply the program. Things work just fine. And then one day they say, "Hey, Steve, our metal precipitant isn't working. We're getting dinged on lead." And go, "Well, what the heck's going on?" We're looking around, we're trying to figure it out. We test the wastewater, and we find it has a tremendous amount of chelate in it. And you can think of chelate as something that binds to contaminants and essentially makes it immune to the chemical treatments we're trying to apply to remove it from the wastewater. And lo and behold, the guy running the floor scrubber decided to empty out his floor scrubber tank into the wastewater pit.
Wow.
Right? And just something that simple
Yeah.
can throw off the entire process
Yeah.
and, cause challenges for compliance.
And I'm, from the cleaning industry, I can imagine that guy had no idea what he was doing was wrong. No one told him. He thought that's a pile of dirty water, and all dirty water is the same and goes to the same place. And,
No, certainly not malicious, just a lack of understanding. And,
right.
and quite frankly, that's the nature of wastewater. I mean, it's kind of the nature of all water treatment is it's a little bit of a thankless job when things are going great.
Yeah.
But when they're going wrong, all eyes on you.
It could be a national story.
It could be.
Well, I'm glad that you're in the trenches on this.
Appreciate that.
To transition a little bit into, because I know a big part of consulting is trying to find ways to be more efficient, to save money, to make your assets last, trying to get your assets to last longer. Tell me a little bit about how water treatment plays into these, to these things.
I mean, it plays a tremendous role. For most facilities that use, say, a cooling tower, cooling water can be 40 to 50% of their total water usage. So if you can do things to limit that while still maintaining clean and efficient systems, it can have a huge impact on the bottom line. So when it comes to boilers and cooling towers, part of that efficiency comes from maintaining the efficiency as created by the original engineer's design and the manufacturer's design for your heating and cooling equipment. And part of it is running those systems so that they're using energy and water efficiently. When it comes to wastewater, you're predominantly concerned about compliance, because when you're out of compliance, that means surcharges, it means hauling fees, and like I said, it could mean downtime, which is an even greater cost. So water usage and water treatment plays a tremendous role in the bottom line of a business, even if it's not often looked at that way.
Mm-hmm. Do you see trends in the industry that facilities professionals should be aware of in terms of water treatment or new technologies?
Yes and no. I'm not averse to new technology, but I often find that a lot of the latest and greatest new technology, specifically non-chemical approaches, or green initiatives, are often better theoretical than in practice. And there is still very much a reason that technologies that have been around for 50, 60, even 100 years are still often the best practice. But we're definitely doing things better than we have in the past. I mean, for example, chrome or chromate was an excellent corrosion inhibitor for many, many years. But what did it do? It put chrome into the water, into the water supply, into the watershed, and that was really bad for the environment. So we don't use that anymore, even though as a functional chemistry, it worked extremely well. in terms of wastewater treatment, I mean, our ability to treat hazardous waste has only gotten better. Oversight and permitting and compliance has gotten much better. My dad would make comments when he grew up in Kalamazoo, Michigan, about how the Kalamazoo River would run white from paper mill discharge. And we don't do that anymore, right? And so where I come in, and what is often a difficult but necessary area of my job, is towing the line between compliance and environmentalism, but also a friendly business environment.
Right.
And that can be really difficult because oftentimes the two butt heads.
Right.
And you have to come up with solutions that are not only cost effective, but also maintain compliance. I do a lot of work with Michigan's Eagle.
Is that the mining company?
Was that?
I was wondering if is that the mining company?
No, not mining. Eagle is actually Michigan's EPA regulation arm.
Oh, okay.
And so there's lots of facilities in Michigan that aren't near or can't connect to a publicly owned treatment facility. And when they can't do that, they're under extraordinarily strict guidelines for discharge directly to the watershed. And for good reason. Because you don't want water laden with mercury and arsenic and zinc and all these things going, right to the creek that is going to go into your lake. But at the same time, sometimes you run into situations where it's just cost prohibitive. And so there are certainly instances where facilities just can't operate. And Michigan is a bit of a unique case. We have some of the strictest discharge guidelines for those types of permits in the country because we're sitting smack dab in the middle of the Great Lakes. And I think we could both agree that, we don't want the Great Lakes polluted.
Absolutely not.
Yeah. Actually, I'm sorry, Matt. I got to plug in my computer here.
Okay, no problem. Do what you have to do.
I don't want to lose you here.
No problem. If if someone is looking to get into the industry, you said that your road was maybe a little bit less conventional. But if someone's looking to get into it, what do you think the best way to do so is, and what's the route?
I would say I would say if you like technical sales, if you like talking to people, if you like selling things, if you like problem solving, and you don't necessarily want to be stuck at a desk all the time, water treatment's a great career. If you like consistency and you like having kind of a big team around you, it's probably not the place for you. It's a lot of windshield time. My closest coworker's 4 hours away. But if you do want to get into it, definitely study engineering, chemical engineering. Biology would work too. But more than likely, the best starting point would be with one of the large companies. There are several well-established, large global firms that tend to hire a little bit more, and they tend to have a lot of training and technical training that will give you a good baseline. I wouldn't recommend going about it how I did. Kind of felt sometimes like I worked my way, like I backed up into it, and that just made for a lot of painful learning mistakes.
Yeah.
Yeah,
I can relate to that as well. Great. This last little section here is kind of a few fun questions, little rapid fire segment. Your go-to brand of tools you like to use?
I mean, I'm a Milwaukee fanboy.
Okay.
I like Milwaukee. I like Klein, and can't go anywhere without my channel locks.
Okay.
But yeah, I have a Klein tool bag that has been with me since the beginning,
Uh-huh.
and it shows the scars of hundreds of facilities and hundreds of projects that I don't know, a little something I take pride in.
Yeah. No, I think everyone's got an item like that.
Yeah,
Do you carry a certain pocket knife or utility tool in your pocket?
Benchmade, Benchmade
Nice.
pocket knife,
Cool.
and always got to
Uh,
have a good flashlight on you.
yeah, that too. Coffee or energy drinks?
Oh, coffee,
Or both?
coffee. I'm hooked on the bean, brother.
Coffee. Nice.
I too much so.
Favorite lunch spot? Or are you bringing lunch from home?
You know what? I have
Are we
I
brown
have
bagging it?
begun
Or
I have begun to bring lunch because there's just not a lot of great food options. But I am an absolute sucker for the American diner. One of my favorite things to do when I'm on the road, especially if I'm in a place I've never been, is to find a local diner. Yeah, that's one of the little joys in this job is
nice.
finding a great local diner and just getting to experience, I don't know, just that part of America, which I love.
Yeah. Most satisfying part of your job?
It sounds a little cliche, but solving a problem, especially one that has been a thorn in someone's side for a long time.
You were also just saying that you spend a lot of time driving, from place to place, and you're not really in a big team, right? So you must spend a ton of time with your customers, and that interaction, those relationships have to be pretty satisfying as well.
Yeah, they are. I mean, and that's also what's really fun about this job is you have tremendous autonomy, both good and bad. I mean, you gotta self start all the time, but it also means that heck, if you want to take your customer golfing, take them golfing. Right? If you wanna take them on a charter fishing trip, take them fishing. There's a tremendous amount of freedom in this job.
This is the last of the fun questions, and we'll get out of here. When you see a facility that you've never seen before on the side of the road, what stands out to you? What are you looking for on that building? We've all
I'm usually
got
look.
that. We've all
Yeah,
got that one thing.
I'm looking for three things.
Yeah.
You're looking for cooling towers. You're looking for a big evaporation plume to see if they're running cooling. You're looking for a deaerator stack, which is like a 3 to 5 foot plume coming from a steam boiler deaerator.
So you're looking for big plumes.
I'm looking for big plumes, and then you're looking for I look for what's called an equalization tank, which is typically a large tank sitting outside the building that is where the wastewater is being stored. The more you see them, the more you start to recognize that place probably has a big wastewater treatment plant. Yeah.
Okay.
Or lagoons. That's another one, which are basically big holding ponds.
Uh-huh.
Yeah.
Yeah, when I was thinking of this question, I thought, every building service contractor that I talk to, or even, facility manager, there's certain things that they look at. The window guy is going to be counting windows,
Yep.
So cool. Well, Steve, thank you for joining the show and, helping us understand more about water treatment and what you do. Thank you for coming on. I appreciate it.
You bet, man. Anytime.
All right, everybody, if you enjoyed the episode, please make sure to like and subscribe to the Facility Focus podcast. See you next time.